Welcome to the bada video lecture. In this lecture, I'll explain the bada UIX namespace. The UIX namespace contains special UI features that are not covered by the UI controls. The bada UI extensions provide ways of using the device in unconventional ways and gives you access to the built-in sensors. In this lecture, I'm going to talk about all the main features of the UIX namespace. The face detector and recognizer enable your applications to detect and recognize faces. The haptic class lets you control and play vibration effects on the device. The sensor manager class enables your application to receive information from the device's internal sensors. The weather sensor class enables your application to receive the day's weather information. Then we have text-to-speech and speech-to-text services, which uses speech synthesis and converts text-to-speech and speech-to-text. Now, let's learn more about the bada UI extension, aka OSP UIX. This namespace provides ways of using the device in unconventional ways and gives you access to the built-in sensors, such as the acceleration and tilt sensors. The face detector and recognizer enable your application to detect and recognize faces in pictures or video streams. Then we have the text-to-speech and speech-to-text services. As you know, the text-to-speech class synthesizes speech from a given piece of text and plays it. So, this feature can enable your application to implement voice-driven features, such as a note reader and talking dictionary. It also supports various properties, such as the locale, voice type, and speech rate. The speech-to-text class recognizes speech and converts it to text, so that your application can implement voice-driven features, such as dictating a note, controlling your application by voice, and voice chatting. It also supports various properties, such as locale, grammar, silence detection, a profanity filter, and punctuation override. The haptic class lets you control and play vibration effects on the device using different effect types, such as periodic, mag sweep, and timeline. It also provides styles such as smooth, strong, and sharp. Then we have the motion class to detect different patterns of motion. The Sensor Manager class enables your application to receive information from the device's internal sensors. The Sensor Manager manages all built-in sensors using information from the system registry. It finds sensors and monitors their availability. The bada Weather Service uses weather information from a weather service provider. The Weather Sensor class enables your application to receive the day's weather information, such as the humidity, temperature, and other weather-related data from the weather service provider. You can also request a weather forecast. The face detector lets you detect the existence of faces in pictures or video streams. It doesn't tell you who the people are. That's done with the face recognizer. We'll explain more details about these features, along with which APIs are available and how to use them with example code. The face detector class enables face detection features in your application. With this class, your application detects the existence of faces in pictures or in video frames. Face Detector handles bitmap images, camera previews, and video frames as input and outputs information about face positions. Detect faces from still image N API is used to search for faces in a still image. It returns a list of the detected face positions. The Detect Faces from Video Stream N API is used to search for faces from a video. It returns a list of detected face positions. Using the Face Detector Set property, you can set the maximum number of faces to detect and the minimum ratio of detectable faces relative to the input data. The ranges are from 1 to 3, where 1 detects small faces and the execution time is highest. Here, I'm presenting a code snippet to detect faces from a still image. Let us first create a face detector object called detect. Then, we'll initialize this instance by calling its construct method. Now, we're going to call detect faces from still image N of detect. The detect faces from still image N method is provided with the image data buffer, input image width and height, and color format. On a successful return, the list will contain a list of detected face rectangles. getCount provides the total number of faces detected, which we can use to loop through all the detected faces. Using the Face Recognizer class, you can implement the face recognition feature and let your application recognize people in images or videos and match them to an internal database. The Face Recognizer takes the image or video input and outputs a list of UIX, face recognition info instances for each face in the image or video. A face recognition info instance contains the position of the face along with information to help identify it. To retrieve the position of a recognized face, you can use the getFacePosition API provided by the Face Recognition Info class. The getFaceFeatures API enables you to retrieve the facial features of a recognized face. Let's go through the code snippet to recognize a face in a bitmap image. In this sample, p_byte_buffer is a pointer to the byte_buffer class. I've decoded the image data into the buffer and assigned it to a pointer, p_byte_buffer, to locate it. Then, I declared and initialized a face recognizer object, rec. Using the extract face info from still image N method of the face recognizer object, I've extracted the facial template that represents the face from the still image and stored it in a list. Now we can loop through the list of faces and compare the face to be recognized with each face in the list. True is returned if the match is found. Otherwise, false is returned if the match is not found. Haptic lets you control and play vibration effects on the device using different effect types. There are 3 motion events in which the device moves. These are double tap, shake, and snap. In the following slides, you'll learn about haptic effects and motion events with examples. The haptic class lets you control and play vibration effects on the device using different effect types, such as periodic, mag sweep, and timeline, and styles such as smooth, strong, and sharp. If you want to know the current state of the haptic effect, you can use the getEffectState method. The states supported are not playing, playing, and paused. The haptic effect is not restricted to responding to touchscreen events only. You can control the vibration in response to various other events or when a particular condition is met. For example, In a game, when the player has accumulated certain predefined points, you can play haptic. The most common scenarios where this can be used are playing periodic effects and loading IVT data from an IVT file and playing effects. Now, let's have a look at the major steps in creating and using a haptic. In this sample, I've created a new haptic instance and initialized it using a construct. Then, I connected to the device using the openDevice method. The minimum period effect is taken in order to be able to play periodic effects. Then, I've set the duration to 5,000 milliseconds. In addition, we can initialize other haptic periodic effect properties, such as the magnitude to 5,000 milliseconds, the style to the strong effect, the attack time to 250 milliseconds, the attack level to 10,000 milliseconds, the fade time to 250 milliseconds, and the fade level to 0. Now, we can play the haptic by calling the play periodic effect. We can stop the haptic at the point where we need to stop the effect. For example, when the app has lost the focus. You can see that I used the Stop Playing Effect API for this. Once this is done, we can close the device with the Close Device method. Now, let's explore motion events in the device context. There are 3 motion events in which the device moves in a predefined pattern. These are double tap, shake, and snap. Let's elaborate in more detail. A double tap event occurs when you tap any part of the device twice. Tapping is detected with the acceleration sensor, so any part of the device can be tapped. A shake event occurs when you quickly move the device back and forth multiple times. A shake can last a long time. To accurately capture this behavior, you'll get the start and end of the shake movement as 2 separate events. The snap event occurs when you move the device back and forth along one axis. The motion class allows an application to know about the movement of the device. The information is available in 2 different manners. One is the request method, in which the application probes the state and gets the info. In the other method, the application can register a listener and receive an event when some movement is observed. Let's go through the motion event listeners one by one. For each type of event, if the application has registered listening to that event, the event is triggered to the application when it occurs. When on double tap detected occurs, double tap events are received. When on shake detected occurs, shake events are received. The various states of a shake motion are started, in progress, ended, and canceled. When on snap detected occurs, snap events are received. The types of snaps are snaps to the positive X, Y, or Z axis, and snaps to the negative X, Y, or Z axis. Let's go through the basic steps for motion application. To attach the motion event listener, inherit your class from the iMotion event listener. Declare a motion class pointer as your private variable, which we will later use to instantiate and initialize an object. Then, you need to override the motion listener methods, which you want to handle in your application. Now, let's define the on-app initializing method, where you perform the basic initialization processes. First, create and initialize a motion object, and then select the motion types to listen to. In this sample, I'm listening to a shake and snap, which I have set using the setEnabled method. Let's go through a simple example of a motion listener. First, we'll consider the Snap Motion Listener. Add the Snap Motion Listener to your application and handle the OnSnap Detected event. Inside the OnSnap Detected method, you can write your logic to handle the snap events. In this simple example, we'll show you the next picture of your album if your device is snapped to the right, and we'll show the previous picture if your device is snapped to the left. In addition to the Shake Motion Listener, I'm going to present an example that if the shake is longer than 1 second, you can discard the picture. First, you need to add the Shake Motion Listener to your device and handle the OnShake Detected event. As usual, to handle the shake events, you can add your logic inside the OnShake Detected method. In a sample, I've retrieved the current time and recorded the start time when the motion started. If the motion has ended and the shake is for more than 1 second, I'm checking with the user if he really wants to erase or keep the picture. Let's learn more about the Sensor Manager now. The Sensor Manager enables your application to receive data from the device's internal sensors. In the following slides, you'll learn about the various types of sensors available with Samsung bada devices. The Sensor Manager manages all built-in sensors using information from the system registry. It finds sensors and monitors their availability. Using the Sensor Manager, you can attach listeners to the sensors and set the listening interval. Samsung bada supports the acceleration, magnetic, proximity, and tilt sensors. The acceleration sensor measures changes in velocity. It can also be used to determine the orientation. The acceleration sensor measures the device's acceleration vector in 3 axes relative to its body frame. The magnetic sensor is a 3-axis electronic compass. It can also be used to determine the orientation. The magnetic sensor measures the magnetic field strength and fluctuations and splits the measurement into X, Y, and Z components. The proximity sensor detects the presence of nearby objects. It reports only on-off information. The tilt sensor combines the 3-axis acceleration sensor and 3-axis magnetic sensor to determine the angular positions, azimuth, pitch, and roll. I'm now going to present an example using the Sensor Manager. First, create a Sensor Event Listener object, Listener. Then, create and initialize the Sensor Manager instance, Sensor Manager. Now, add the required sensor listeners to the Sensor Manager. It's always wise to check the availability of the sensor before adding the listeners. In this example, I've used the acceleration sensor. In addition, you can add listeners for more sensor types, such as the magnetic, proximity, or tilt sensors. Let's go through the basic steps of defining and implementing a sensor event listener. First, you're going to need to define your listener class by inheriting the sensor event listener. Then, implement the sensor event listener by overriding the method onDataReceived. Inside this method, you can handle different types of sensor data. In this sample, I've used a switch case sensor type for this purpose. Next, let's discuss the weather service. The weather sensor enables your application to receive the day's weather information, such as the humidity, temperature, and other weather-related data from the weather service provider. You can also request a weather forecast. Using the weather sensor, you can request the current weather information or weather forecast for a location. The iWeather event listener interface has event handlers that are invoked when the weather data is received from the server asynchronously. The current weather class stores the current weather data, such as the humidity, temperature, pressure, or wind details. GetCondition is the method to retrieve the weather conditions, such as cloudy, fog, frigid, hail, lightning, etc. Using the Weather Forecast class, you can get the forecast for a particular location on a particular date with the weather data and conditions. Let's create a sample weather application. As usual, inherit your Weather Sample Application class from the Weather Event Listener. Then, initialize the Weather Sensor object. Using this object, you can access the methods of the Weather Sensor class. Use the services of the Request Current Weather API to request the weather data for a particular location. Since this is an asynchronous call, the data will be received in the OnCurrentWeatherReceived event listener. As discussed in the previous slide, here we handle the event by overriding OnCurrentWeatherReceived. In this example, I'm printing the weather info, temperature, humidity, and pressure for a particular location. In the application where you create your class object, you need to specify the location for which you want the weather information. Here, we provided the location as Suwon, South Korea. The UIX text-to-speech class synthesizes speech from a given piece of text and plays it. As a result, this feature can enable your application to implement voice-driven features, such as a note reader and talking dictionary. Note that this functionality requires network access. This class supports various properties, such as locale, voice type, and speech rate. You can start the conversion of a given text and start playing the synthesized sound. You'll get options to pause, resume, or stop the synthesized sound. You can also select a male voice or a female voice type. Then, you have the option to check the list of supported locales using the getSupportedLocalesN method. You also get the option to set a different speech rate for the sound. The iText-to-Speech event listener interface is the listener for speech synthesis events. It provides methods that are used to notify when the status is changed or when an error occurs from the voice engine. In the next few slides, I'll present you with the sample code to use text-to-speech. You can create your text-to-speech sample by inheriting iText-to-Speech event listener. You can handle status changes and error conditions in onText-to-Speech status changed and onText-to-Speech error occurred, respectively. In your overridden onText-to-Speech status changed, you can call the text-to-speech method speak with the text to convert. Before calling speak, you need to make sure that text-to-speech is initialized. You can add other code as per your application requirements. In your overridden onText-to-Speech error occurred, you can handle the error conditions. The errors can be service-related, such as the application failed to start, stop, play, or resume, or network-related, when the network connection fails. Let's see how we can implement our initialize method. First, we need to create and construct our text-to-speech object. Using this object, we can initialize the text-to-speech service. Now, let's discuss speech-to-text. The OSP UIX speech-to-text class recognizes speech and converts it to text so that your application can implement the voice-driven features, such as dictating a note, controlling your application by voice, and voice chatting. This functionality also requires network access. This class supports various properties, such as locale, grammar, silence detection, profanity filter, and punctuation override. With this feature, you can record speech and convert it to text. You can also perform punctuation overriding or profanity filtering. In your application, you can easily enable or disable silence detection. As in the case of text-to-speech, here you also have the option to check the list of supported locales using the Get Supported Locales N method. The basic skeleton of the speech-to-text sample application is very simple. You can use the onSpeech-to-text initialize method where you can start converting speech to text using the start method of the speech-to-text class. You can add your code in onSpeech-to-text recording status changed to handle recording status changes. The various recording statuses available are recording started, stopped, or completed. To handle error conditions, you can override the onSpeech-to-text error occurred method. When an error occurs, the user cannot receive any speech-to-text result. The errors can be service-related when speech-to-text fails to initialize, start, stop, or record. The failure can be because of a network error. It can be because the user has canceled the service, or speech-to-text failed to continue because of handling system events with a higher priority. The other type of error can be because of improper input, such as the speech is too short, too long, too loud, or too quiet. You can use the onSpeech-to-text completed method to handle the event when the speech-to-text conversion has been completed. The result string contains the converted speech text. You can print them in your application to display the converted speech. You'll also be notified of warnings, if any, during the process. The warnings can be one of the following: the speech started too soon, the speech is too short, the speech is too long, the speech is too quiet to hear, the speech is too loud to hear, or the speech is too fast to hear. You can have the display method in your sample application to display the converted speech. In your sample speech-to-text sample application, you can have your own initialize method. In this initialize method, you can create and initialize an object of the speech-to-text class. We've just used these speech-to-text event listeners in the previous example. Let's summarize them again. The completion of the speech-to-text service is notified by onSpeech-to-text completed. OnSpeech-to-text error occurred notifies the application when an error occurs in the speech-to-text service. When the speech-to-text service is initialized, this is notified through onSpeech-to-text initialized. The three speech-to-text recording statuses are start, stop, and completed. They're notified through onSpeech-to-text recording status changed. Therefore, with the UIX namespace, we can accomplish face detection and recognition, we can add haptic effects to our applications, and detect motions such as double tap, snap, and shake motions. With the sensor manager, we can use the magnetic, acceleration, proximity, and tilt sensors. The weather info can be retrieved using the weather class. And we can also convert spoken words to text and text to speech.